Okay, Assalamualaikum and good day all. Okay, for this video, we will learn about the introduction of vector value function. Okay, so previously we have come across a function with which is scalar function. Okay, for this time around, we will learn about vector value function. What is the difference between these two functions? Okay, for scalar function only have magnitude or value. Okay, this is usually the function that we used before. Okay, for this time around, vector value function, in vector we have magnitude and also direction. Okay, so with direction we call it vector. Okay, for look at the general form of vector value function for plane. Plane is 2D. Okay. So we noted vector value function as bold rt, a function of t, equals to fti. I is the vector, or the vector we noted as bold I, j. This is refer to direction of x-axis, y-axis, and also for k is z-axis for space 3D. Okay, usually we note it as I, bold I, or maybe I hat. Okay, or I curve. Okay, for written, maybe we usually use this lah because it's hard to write as bold, kan? Okay, so F for space FTI plus GTJ plus HTK. We can also rewrite the function as in brackets only FT, GT, HT in bracket. This. Okay, which F, G, and H is a component function of RT. Okay, so this way of writing, we just write the components without writing the vector. So you know this is for I, J, and K. Okay. So next parametric equation. Okay, parametric equation kita dah pernah jumpa pun sebelum ni. Okay, parametric equation for lines in space. Okay, for lines in space, we have 3D, but we want to the equation for lines, okay, can be written as x equal to x0 plus at, y equal to y0 plus bt, z equal to z0 plus ct. This is actually one lines. Okay. An equation, the equation for the one satu, ini adalah satu garis lah ni. Persamaan dia kita berikan dalam parametrik x, y and z. Okay, or can be written as symmetrical form. X minus x0 over a equals to y minus y0 over b equals to z minus z0 over c. Okay, actually this is all equals to t. Okay, we rewrite this as t. T equals to, from here, t is equal to x minus x0 over a. Right, so we write into this. This is symmetrical form and this is parametric equation form lah. Okay, biasa kita jumpa yang bentuk macam ni. Okay, which means that the line goes through point x0, y0 and z0. Okay, x0, y0 and z0. The line cross the point, this point, x0, y0 and z0, and parallel to a non-zero vector v. Okay, so vector v is a. This is the component of vector b. Vector v, ai plus bj plus ck. So from this one equation, we know two information. The first one is the line goes through the point x naught, y naught, z naught, and also the line parallel to vector v. Okay. So also the parametric equation, this line equation can also be expressed in vector. Okay. In vector form. So this is how we write in vector form. RT is equal to xt, yt, and zt. Okay, x, y, and z. So this is the component. So in it, here the x, y, and z. So we can return the parametric equation in the vector form. Okay. So look at example 3.1. Okay, find a parametric equation and a vector equation. Okay, this one is in the vector form lah. The same line. Find a parametric equation and a vector form of the line. Okay, we want to find the line through the point 0, -2, 1 and parallel to vector v, 3i plus j plus 3k. Okay, so we have two information here through the point. So this is x naught, y naught, z naught. And parallel to vector v, 3i plus j plus 3k. So this is ai plus bj plus 3k. Okay, so we know the value for a, b, and c. Then determine the intersection. Okay, first we want to find the parametric equation. So parametric equation, x is equal to x naught plus at. Right? So x is equals to x naught 0 plus 3t. Y naught plus bt. So y naught -2 plus b is equal to 1t. Z is equal to z naught plus c t. Okay, this one is c. Okay, which is equal to z naught 1 plus 3t. Okay, so this is the parametric equation. So if we want to write into the vector form, we can write as RT. Okay, follow the formula here. Okay, xt. So the component for I direction is 3t. So 3ti plus yt. So yt is t minus 2j plus z. 1 plus 3t k. So we have answered the first one, find the parametric equation. So this is the parametric equation and the vector form. So this is the vector form. Then determine the intersection point of the line and the xy plane. So what is xy plane? So xy plane is z equals to 0. So we let our z equal to 0 here. When z equal to 0, so 1 plus 3t, so we have t. 3t is equal to -1, so t equal to -1 over 3. Okay, so just substitute into x. X is 3 times -1 over 3, so equals to -1. Y equals to t minus 2. Okay, our t is equals to -1 over 3. So here, -6 over 3, so -7 over 3. So this is x, this is y. And z is equal to 0. Okay, so the intersection point is -1, -7/3 and 0. Intersection points. Okay. So hopefully you can understand. And we will do exercise. And later I will set at author. Okay. For next one is vector operations. Okay, for vector operations, previously, this is our previous knowledge from secondary school or maybe from diploma stage. Okay, when we know the vector operation is these are the vector operation. Okay, so let A is a vector of AI. A1i plus A2j plus A3k and B1i plus B2j plus B3k. So these are the vector operation that can be applied to the vector. So the first one is dot product A dot B. The second one is cross product. Okay, these two are multiplication, but for vector we have two kind of product. So the first one is dot product, and the second one is cross product. Okay, for dot product, we just multiply the component of its vector. So A1 times B1 plus A2 plus B2 times plus A3 times B3. So here for dot product, the product or the multiplication of A dot B is a scalar. There's no component of I, J and K left. So kat sini kita hanya dapat scalar O, means value only. Okay, for cross product, we do cross product A cross B. So this is how we do the cross product. Okay, we must write into this bracket. So I, J and K. So this is the component for A, A1, A2, A3, for B, B1, B2, B3. So how to do the cross product? Okay, this is actually you have learned before, your previous knowledge. For the I component, we close first the I. So this is for I. So the left, the remaining is A2 times B3. A2 times B3 minus, minus A3 times B2. So this is for I component. We close the column of I. So next, minus. Minus is the formula. Okay, for J component, okay, we close J. So next, we do multiplication A1 times B3 minus A3 times B1. J. Okay, this one is for J. Okay, for K, close the K component, so plus, so the formula is plus. So A1 times B2 minus A2 times B1. This is K. So these are the methods to find the cross product. Okay, so for cross product, we still have vector here. So still have the I, J and K. Okay, that is for cross product. For magnitude, okay, magnitude of A. Okay, A is a vector, so we want to find the magnitude of A. So this is the notation for magnitude. A is actually square root of A1 square plus A2 square plus A3 square. So this is our A. So hasil tambah A1 square plus A2 square, A1 square, A2 square, A3 square, and all in square root. So we have the magnitude. Okay, we also can find the direction of the movement, which is its unit vector, A over its magnitude. Okay, this is still vector. Magnitude is a value. We have value or scalar. Okay, the fifth operation is differentiate A dot B and differentiate A cross B. So actually for this is still using multiplication or product rule. For example, differentiate UV from our previous. So UV prime plus VU prime, right? So the same formula, but now we are doing dot or cross. Okay, for dot, A dot B prime plus B dot A prime. Okay, the same formula, the same product rule formula, but you must be careful for dot product. But for cross, A cross B prime plus B cross A prime. Okay. So how to do the dot and the cross product? Okay, we have discussed earlier dot product and the cross product. Okay. So for example, please do this as your example. Given A and B, and then find A dot B, A cross B, magnitude of A, and differentiate A dot B, differentiate A cross B. Okay, I will set that at author. Okay. So till we meet again, that's all for this time. Thank you.